All right, so to introduce what we're doing today, I want you to take this equation, it's a quadratic equation, and solve it using the square root method. So if you remember, what we do is we're trying to get the x squared by itself, and then take the square root of both sides. Go ahead and give it a try. All right, so what should have happened here, right, is we add the 7 over. 5x squared equals -5, divide by 5. So x squared equals -1. And then we got to take the square root of both sides. So x equals plus or minus square root of -1. Okay, and what we've talked about a lot, over the last few lessons is square root of a negative doesn't work, right? You can't square a number, at least a real number, and get a negative. But there are a lot of quadratic equations or polynomial equations that when you go to solve, you end up with the square root of a negative number. And so what happened is over time, mathematicians came up with a way to deal with these type of answers, with these type of numbers. So it's not a real number. What they did is they said square root of -1 equals I. So they just gave it a name. And I'll kind of show you how that can help us simplify things here in just a second. And the I stands for, you guys are going to love this, it stands for imaginary. So up until now, all the numbers you've dealt with have been real numbers. Well, there's this other group of numbers called imaginary numbers. And sometimes that bothers us because of the name imaginary, but it's just a name. Okay, they're real, they exist right here, right? I got the square root of -1. So imaginaries are actual numbers. They're just a different type of numbers. Okay, so what we're working on today is just working on taking imaginary numbers, and we're going to add and subtract them and multiply them and divide them. We're going to take radicals and simplify them. When there's negatives, you'll end up with an imaginary answer. So that's kind of what we're working through here. This says I can simplify, add and multiply complex numbers. We'll talk about what that complex part means right there in just a second. Okay, but let's just start with this very first thing is we're going to take square roots and simplify them down, square roots of negatives and simplify them. So up until now, if you look at this A right here, and we had a problem like this, we would just stop and say, well, that's not possible. There's no real number you can square to get -25. And that is true. There's not a real number you can square, but there is an imaginary number. So we're going to take this and simplify it. So I'm going to take it and break it apart. The way I do that is think of -25 as being -1 times 25. Then I break those two apart. Square root of -1 times the square root of 25. Square root of -1 is I, and square root of 25 is 5. So we got 5 times I, or 5I. And we're done. That's my answer. So square root of -25 equals 5I. So really, you're just going to be simplifying square roots, similar to what we've already done. The only difference is you're first going to have to pull out the square root of -1, and that will leave you with something like the square root of 25 that we can simplify. Okay, let's look at B. So I got the square root of -72. So the very first thing, as soon as I see it's a square root of a negative, is I'm going to pull out the square root of -1. That becomes I. The square root of 72, I'm just going to simplify like we have before. So, right, 72 is 8 times 9. 8 is 2 and 4. 2 and 2. 3 and 3. It's supposed to be a 3 there. So I've got a pair of 3s and I got a pair of 2s. So 3 times 2 is 6. I have a 6 on the outside. And then I have that 2 left over. Okay, now the way we write, so that's my answer. That's simplified as far as we can go. But the way we write it usually is I put the 6 first, the I second, and we put the radical, the square root on the end. So square root of -72 simplifies down to be 6I square root of 2. C is pretty similar to that. It's got that -5 out in front. That's just -5 times, and then I just have to simplify the square root of -9. So that would be square root of -1 times the square root of 9. That's I. That's 3. So I end up with -5 times 3I times those. You end up with -15I. Okay, I want you to try a couple. Why don't you guys simplify 1 and 2? So pause the video, simplify those two, and then I'll go through them with you. Square root of negative 4, again, break out the negative 1. That's I. That's 2, and we write the answer this way, just as 2i. Square root of negative 12 would be the square root of negative 1 times the square root of 12. That's I. I got to break apart the square root of 12. So that's 4 and 3, right? So I end up with a 2 on the outside, and I got a 3 left over. So square root of negative 12 simplifies down to be 2i square root of 3. Be careful on problems like number 3. If you have a negative out in front, that you cannot times that through. So the negative just stays there, and then I'm just going to simplify the square root of negative 36. So that would be the square root of negative 1 times the square root of 36. That would be I. That would be 6. So you end up with negative 6i. Okay, so that kind of shows you where the imaginary comes from, the I. It comes from that square root of a negative. And we can always simplify it by breaking off the square root of negative 1 and making it I. So let's kind of summarize the different types of numbers we know then. So if you want to make this rectangle in your notes there, we're going to talk about the complex number systems. We're going to put that at the top. So complex numbers. Complex numbers are any numbers that could be written as a plus bi. So they have a real number part. The real number part is the a. Then they have an imaginary number part, which is the bi. Okay, within the complex numbers, there's 2 different subsets. So one of them are numbers that you're familiar with, and that's the real numbers. And those are all the numbers we've been doing up until now. They include rational and irrational. They include the natural numbers, whole numbers, integers, all those number sets you've done up until now. The other half of complex numbers, though, are imaginary numbers. Okay. So real imaginary numbers are numbers like this. You could have, for example, 6i. That's an imaginary number. So 6 is the b. The a would be 0, so there's nothing there. It's kind of like having a 0 plus 6i. Now, you don't need to write the 0. But, you could have, 2 minus 7i, 5 plus 3i. Like, those are all examples of imaginary numbers. Real numbers, they have to still be written in this form of this a plus bi, but it's like this. 3 is a real number. Well, we might ask ourselves, well, how could I write 3 that way? Well, it would just be 3 plus 0i. Or I could have a half. A half is a real number. Well, that's a half plus 0i. Or you could have the square root of 7. That's a real number. Well, how would I write it that way? It'd be square root of 7 plus 0i. So if it's a real number, what happens is the b part always equals 0. In other words, there's no I. Imaginary numbers, the b does not equal 0. So long story short, what you have to understand is just this. If complex numbers include both real and imaginary numbers, real numbers don't have an I. The imaginary numbers do have an I, just to make it simple. So what we're going to do is add and subtract and multiply these complex numbers. So this says add or subtract, write the answer in standard form. So I've got 8 minus I plus 5 plus 4i. Well, this is just like if I gave you, we did problems similar to this. If I gave you this problem, 8 minus x plus 5 plus 4x. We did this back in Unit 2 when we talked about adding polynomials. All I did is wrote them without the parentheses, right? Then I combine like terms. 8 plus 5 is 13. Minus 1x plus 4x is 3x. And we got it. Well, we do the exact same thing here. So the i's, treat them, it's not a variable because I is the square root of negative 1, but we're going to treat them like a variable. So we're going to go write them without the parentheses, 8 minus I plus 5 plus 4i. Okay, now we're just going to combine like terms, 8 plus 5. Right, those are like terms. And then I have minus 1i plus 4i would be plus 3i. That's as far as we can go. By the way, when you write an answer, we're always going to write it in this form. So the real number part comes first, and the imaginary part, the I part, comes second. This is pretty straightforward. The trickiest part is really with a minus. So just remember, if you look at B here, If I write it without the parentheses, I get 7 minus 6i, but that minus has to carry 3 to both. So it becomes minus 3, and it becomes a plus 6i. So make sure the minus carries through the parentheses. Now combine like terms, I got 7 and a minus 3, 4. Got a minus 6i plus 6i, that's 0i. So really that's just 4. Let's scroll down here. I want you guys to try. I want you to try these two. Why don't we try 7 and 9? So pause the video, try those two, and then we'll come back and go through it together. So if I write this 7 without the parentheses, it'd be 9 minus I plus, well, plus negative 6 would really just be a minus 6. So minus 6 plus 7i. Combine like terms, I got the 9 minus 6 is 3. I have the minus 1i plus 7i. Minus 1 plus 7 is 6. So we end up with 3 plus 6i. Number 9, I got three complex numbers I'm adding. So I got negative 4. I'm going to carry that minus through. Minus 1 minus I. Minus 5 minus 9i. So just make sure those minuses carry through to both. Okay, combine like terms. I have a minus 4 minus 1 minus 5. That's a minus 10. And I have a minus 1i and a minus 9i. That's a minus 10i. Okay, and we've got it simplified. So the nice thing about this is if you think back to how we added or subtracted polynomials, we're doing the same process here. It's just with i's instead of x's or other variables. Multiplication is also similar, but before we do that, one thing just to know, if I tell you that I is equal to the square root of negative 1, what do you think I squared would equal? So just think about that for a second. All right, see if this makes sense. If I take the square root of negative 1 and square it, the square root and the square are just going to cancel out. So I squared equals negative 1. This is really important. That's going to be really important to us as we go through and multiply. So if you don't have that written down, I equals the square root of negative 1, I squared equals negative 1. Make sure you have that written down. Okay, other than knowing what I squared equals, this is pretty similar to just multiplying polynomials, right? So I just take the 4i and just distribute it through. So that'd be minus 24i. That would be plus 4i squared. So now, if these were x's, we'd be done, right? They're not like terms. I can't add them together. But here's the thing. The I can't simplify because I is the square root of negative 1, and we can't simplify the square root of negative 1. But the I squared I can simplify because I squared is negative 1. So I can do something with that. So I'm going to go negative 24i plus 4. This is 4 times I squared. So I'm going to go 4 times, and replace that I squared with negative 1. So I've got negative 24i. 4 times negative 1 would be a negative 4, so it'd really become a minus 4 right there. Those are still not like terms, so I can't combine them, but I can rewrite it. I'm going to write it this way, negative 4 minus 24i, right? Write it in that form, that a plus bi form. So really you're just multiplying like we normally do. The only catch is if I end up with an I squared, you've got to change it to a negative 1. All right, let's try this next one, try B. So I've got 9 minus 2i times negative 4 plus 7i. Okay, now I've got two terms and two terms. I still have to distribute, but I have to distribute twice, right? We have to do that FOIL method. So I'm going to go 9 times negative 4, negative 36, 9 times 7i, negative 2i times negative 4, be a minus 8i, minus 2i times 7i would be a minus 14i squared. Okay, I get to here, I can combine some like terms. Those two are like terms, so negative 36, 63 minus 8 is what, 55? 55i. Minus 14, but that I squared changes to negative 1, so 14 times negative 1. So now I have negative 36 plus 55i. Minus 14 times negative 1 is a positive 14. And now that I did that, these are actually like terms now, so I can add those together. So negative 36 plus 14, I think that's negative, what, 22 plus 55i. And And that's really as far as I can go. Those are not like terms. I wrote it as a complex number and we're good to go. So you're multiplying out like we normally would. The only difference is if you have an I squared, you have to change it to -1 and you can simplify a little bit further. And that's really the last thing we need to do. So let's just practice. I want you guys to try 12 and 14. So pause the video, try those two, then come back, we'll go through it together. And if we get that, we should be ready to work on the practice. All right, so this one, you only have one term and one term. Just multiply them. -3 times 10 is -30. I times I is I squared. So -30 I squared. That I squared right there changes to -1. So -30 times -1. So +30. And we're done. Okay, on this one, number 14, we have to distribute. So 3 times 5 is 15. 3 times a minus I is a -3i. I times 5. And then I times a minus I would be a minus I squared. Okay, see what you can do to simplify, combine those together. 15 plus 2i. And then minus I squared, that becomes a minus, and the I squared is a -1. Switch it to be a -1. So 15 plus 2i minus -1 is a +1. Add the 1 to the 15. Just combining like terms. Write it in the right form, and there's my answer right there. All right, so hopefully, again, our goal is we understand what imaginary numbers are. You get imaginary numbers when you have the square root of a negative number. Okay, and then we want to be able to add, subtract, and multiply. And we've done examples of all of those. All right, thanks, guys.